Hello everyone, my name is Oğuzkan. In this tutorial, I will talk about simplified absorption and pharmacokinetic models in GPX. For this tutorial, we will use an example project based on metformin. Then, we will create a simplified absorption model in the metformin project and finalize the tutorial with the application of a simplified systemic pharmacokinetic model. Before getting into GPX, I would like to give brief information about the metformin example project. In this example, we will use one clinical pharmacokinetic study that had two different groups of subjects which received different formulations of metformin hydrochloride. The first group received 500 mg of IV bolus, whereas the second group received 500 mg of peroral tablet. Since the doses in the study administered as metformin hydrochloride salt formulation, we converted the weight of the salt formulation to the free base formulation, and we will use this number for the GastroPlus simulation. In this study, bioavailability is reported around 60% for 500 mg tablets without any metabolism. This shows that the systemic clearance comes from the only renal clearance. This project already has a two-compartment model set up using the parameters shown here, which were fitted to the IV data. We also have here the parameters we will use for the simplified absorption model. These have not yet been added to the project, but have been fitted to the PO data from this clinical study. Currently, we are in the metformin example project in GastroPlus X. Before the application of simplified absorption, I would like to review the assets and settings already in the project. In the observed data view, I have added two observed data series for concentration and plasma versus time graphs for the two different administration. I have also added the details about the dose administered and the average body mass of the study group in the study to the observed data. In the compounds view, there is only one compound, which is metformin, and I edited some parameters based on the literature findings in the panels here. No enzymes and transporters have been added to this compound in this example. In the dosing view, under the formulations panel, I have created two different formulations, one for IV bolus and one for peroral tablet. In the dosing schedules, I have created two different dosing schedules representing two different administration in the study. In the physiologies view, I have created two physiologies representing the two groups in the study. Since we are using a compartmental model initially, I did not create peer physiology or PBPK models. In the pharmacokinetics view, I have edited the blood-plasma concentration ratio and experimental fraction and bound in plasma based on the literature data. Under the compartmental panel, I have added a two-compartment model using the parameters fitted to IV data. In simulations view, I have created two simulations, one for each administration in the study. Let's run the IV bolus and observe the results. Here, we can see that the simulated curve has a perfect agreement with the observed data as expected. This shows that disposition of the drug is successfully represented. Now, I will navigate back to simulations view and select the peroral tablet simulation. In this simulation, we are using compartmental model as we are using for the IV bolus. So I will run the simulation. As we can see in the result, simulated curve does not agree with the observed data. Since we are using the IV bolus compartmental model, it is clear that the problem originates from the absorption phase. In this example, we will show how to use a simplified absorption model to capture the observed data with a fitted absorption rate constant, or Ka. In order to apply simplified absorption, I will navigate to dosing view and expand the formulations panel. I will create a new formulation and call it simplified. Then I will choose a simplified dose for the route, as simplified absorption models require this formulation type. Then I will expand the dosing schedules panel, and I will copy the peroral tablet dosing schedule record. And I will rename it as simplified. Then, I will change the formulation type of this dosing schedule record to simplified. Now, we are ready to apply simplified absorption to the simulation. I will navigate back to simulations view and copy the peroral simulation. And I will add the extension of simplified right after the peroral tablet naming. Then I will change the dose schedule to the simplified, and then I will change the gastrointestinal model from ACAT to simplified. Before proceeding further, I would like to talk about what happens to model when we change the absorption model from the ACAT model to the simplified absorption model. In this case, connected to a compartmental systemic model. On the slide, we can see a diagram depicting the ACAT model connected to a compartmental model in GastroPlus. On the upper part, the ACAT model is represented. Some portion of the drug in the ACAT model will reach the systemic circulation, which is synonymous with the central compartment. Then the drug will distribute to the compartmental liver, and then the drug will distribute to the peripheral tissues based on the compartment number assigned in the compartmental part. If we change the gastrointestinal model from ACAT to simplified, the ACAT model will be replaced by one absorption compartment. The flux from this compartment to the systemic circulation is determined by the absorption rate constant and time lag. Portion of the drug reaching to systemic circulation can be limited by fixed simplified first-pass extraction, which removes a defined percentage of the drug, similar to other fixed FPE settings in GastroPlus. Also, enterohepatic circulation, or EHC, is disabled for the simplified absorption models. The remaining part of the compartmental model will be same as the previous slide. Please note that absorption compartment can be used to represent gastrointestinal absorption, but it is not limited to it. It may also represent absorption from muscle, skin, or any other relevant routes of administration if the modeling purpose permits. Moving back to GPX, now we can assign the parameters for simplified absorption. These parameters are the part of the simulation settings as they are linked to the compound, formulation, and the physiology. And the simulation is where the assets are combined. Under the compound settings, I will set the simplified first pass extraction to the 35%. Then, I will scroll down and expand the simplified absorption subpanel. Over here, I will edit the absorption rate constant as 0.36 per hour, and I will keep the time lag as 0 hours. Then, I will run the simulation. Here, we can see that simulated curve has a good agreement with the observed data, which shows that the simplified absorption model can capture the absorption model for this particular dose. The details about the simplified absorption process can be investigated in the deep view and under the simplified dosing option here. Over here, the user can get the details about the absorptive compartment and also the rate constant over time. As we can see over here, the absorption rate constant is not changing because of the simplified absorption process. Currently, we are done with the application of the simplified absorption. Now, I will show how to apply simplified pharmacokinetics. I will navigate back to Simulations view and change the pharmacokinetic model to simplified right over here. In comparison to traditional compartmental models, the compartmental models in GastroPlus have an additional liver compartment, which allows for nonlinear enzymatic clearance. This corresponds to the compartmental liver location in the enzyme kinetics table. When we change the systemic model to simplified, the liver compartment will be removed, which means that nonlinear elimination cannot be assigned to the model anymore. The remainder of the simplified systemic model is the same as the compartmental model, and is still based upon the compartmental model defined in the pharmacokinetics view and selected in the simulation settings. So let's run the simulation and observe the results. Here we can see that the results are not changed and are still in good agreement with the observed data. This is because we have not assigned any enzyme to the compartmental liver previously, so changing to pharmacokinetic model to simplified didn't affect our results. However, if you look at the deep view, we can see that the compartmental liver option is no longer available here. Please note that simplified absorption models can be connected to PBPK systemic models, where absorbed drug enters venous return directly. Also, the simplified systemic model can be combined with the simplified absorption model. It cannot be used in conjunction with the ACAT model. Thank you for watching our tutorial. If you have any questions regarding to this tutorial, we can be reached through these emails.